Okay, good afternoon, class. Sorry I'm out again. So it looks like I won't be here tomorrow either, unfortunately. I'm thinking Thursday I'll be back. But I want you guys to keep up on your homework, so I'm going to have you turn in a homework packet tomorrow with Monday, Tuesday, and Wednesday's homework. That way you guys are not just waiting until Thursday, because I don't want you to fall behind. Easton will be here after school for tutoring. I highly suggest you come in both this Tuesday or today and Thursday this week. I don't want you falling behind. Let's have some good habits for this new chapter. All right, so let's talk permutations and combinations. So kind of going to build off of what we did yesterday. So let me read this out to you. When the manager of a softball team fills out her team's lineup card before the game, the order in which she fills in the names is important because it determines the order in which the players will bat. Suppose she has 7 possible players in mind for the top 4 spots in the lineup. You know from the fundamental counting principle that there are 4 spots. 1, 2, 3, 4. So she picks her first one, then she has 6 players left to pick her second, and she has 5 players left to pick her third, and 4 players left to pick the 4th top spot. So that's what they've done here. 840 different ways that could be chosen. Okay, so there's another way to look at this. This is the notation for it. 7 permutation 4, or there's 7 players, and out of the 7 we're going to pick 4. This can also be written like this. 7, pick 4. And what this looks like is it looks like this. 7 factorial over 7 minus 4 factorial, which is 7 factorial over 3 factorial, which makes sense because if you think about this, 7 times 6 times 5 times 4 is really 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1, but the 3 times 2 times 1 has been eliminated. Just like this. So because of that, it's 7 times 6 times 5 times 4. So it works out like this. So here's the official formula for permutation. I hate using letters, but that's the way it's going to look in your book, so let's do that. So the number of items over the number minus how much we're picking. So this is for permutation. So you can go ahead and pause the video and make sure you guys get that down. Alright, so let's talk permutations and combinations. Alright, so a linear permutation is the order of objects or people in a line is important. So here, let me highlight some of these. Order is important. And we're going to talk these, and then we're going to start working on some of them together, and I'll show you what the formula is for combinations. Okay, so here's some clue words. Arranging, that's a huge one. Or an arrangement for first, second, third. Here's some examples. Arranging 4 vases of flowers in a row. A lot of times when they say in a row. An arrangement of the letters in math. Here's another one called a circular permutation. The order of objects or people in a circle is important. So again, that word arrangement. We're arranging in a circle. So a keychain, anything that's circular. Arranging 5 glasses in a circle on a tray, or putting charms on a bracelet, those would all be circular permutations. Okay, combinations. Combinations, the order is not important. Order is not important. When you take notes, this is kind of what I want you to write. You don't have to write all of this down. So here's some keywords. Selecting, choosing, forming. So sometimes when I'm doing these problems, if I want to know if it's permutation, I use permutation or pick, and combination is choosing. So if I'm choosing something, I'm choosing it at random. If I'm picking something, I'm purposely picking where things go. So I hope that helps. This is the hardest part of this stuff, is just distinguishing between which one's a permutation and which one's a combination. So here are some examples over here. Selecting 3 of 8 flavors, choosing 2 people from a group of 7. Okay, so let's practice this. Does order matter, permutation or combination? So I'm going to go ahead and read these and then pause for a second and see if you guys can come up with it. So selecting a 4-person bobsled team from a group of 9 athletes. Okay, so that one's a combination. I'm selecting a 4-person bobsled team. I didn't say anything about order, anything about arranging anything. I'm just selecting. So you got to look for these keywords. An arrangement of letters in the word Canada. Let's start highlighting which ones. So selecting made it a combination. Arranging made it a permutation. Arranging 4 charms on a bracelet that has a clasp, a front, and a back. Again, that keyword arranging. That one's going to be a permutation. Selecting 3 desserts from 10 desserts that are displayed on a dessert cart in a restaurant. Hopefully you said combination. Keyword there was selecting. An arrangement of letters in the word annually. Again, arrangement would hint to permutation. Forming a 2-person sales team from a group of 12 salespeople. Forming is not arranging. Making 5-sided polygons by choosing any 5 of 11 points located on a circle to be the vertices. I see the word choosing. Choosing tells me combination. Seating 5 men and 5 women alternately in a row beginning with a woman. I'd say the key word there is beginning with. That tells me that there's order to it. So that'd be permutation. Okay, so let's use this to go through our lesson. So I'll be able to solve problems involving permutations and combinations. I'll be able to explain the difference between a permutation and a combination. So let's get started. A newspaper has 9 reporters available to cover 4 different stories. How many ways can the reporters be assigned to cover the stories? So keyword here to me would be assigned. This is a permutation. So let's see, I've got 9 reporters and we're picking 4. So I would say that would be a 9 permutation 4, or it can be written permutation 9 pick 4. Our formula would be 9 factorial divided by 9 minus 4 factorial, which equals 9 factorial over 5 factorial. Let's go ahead and just put our n factorial over n minus r factorial. So if I put this in a calculator, there would be 3,024 ways. So go ahead and copy that down. All right, how many different ways can the letters of the word decided be arranged? Okay, so arranged, permutation. Only I'm going to give you another formula here for this one. The problem with this is there's repeaters. So I've got 1, 2 E's, and I've also got 1, 2, 3 D's. And that poses a problem. So a repeating permutation a repeating permutation, the formula goes like this. So I've got n, in this case, would be the number of letters. 1, 2, 3, 4, 5, 6, 7. That would be 7 factorial divided by my repeaters. So I'm going to call that r factorial and q factorial. So if r would be one of my repeats, there's 2 of them. So that would be 2 factorial. And if q is one of my repeats, there's 3 of them. So that would be 3 factorial. And to figure that all out would be 7 times 6 times 5 times 4 times 3 factorial over 3 factorial, and then 2 factorial is just 2 times 1. Cancel the 2. Let's put the 2 up here. Got 420. And by the way, there is a way to do this in your calculator, and we're going to be learning that tomorrow. Okay, a family with septuplets assigns different chores to the children each week. How many ways can 3 children be chosen to help with the laundry? Okay, what do you guys think? Is this one going to be combination or permutation? It's a little bit ambiguous. First of all, we got the word assigns here. But over here, when we're talking about how we're picking the children, they are chosen. This is actually a combination. So let me give you the formula for a combination. It's very, very similar to permutation. There's just one little difference. So a combination would be the n factorial for the number. So let's go ahead and fill it in. Septuplets is 7. So we've got 7 factorial. And then the same thing as the permutation, where I'm going to say n minus r, or how many we're going to choose, factorial. How many ways can 3 children be chosen? So that's going to be 7 minus 3 factorial. And then finally, we have to add in how many chosen factorial. That would be 3 factorial. So it kind of works out where you've got 7 factorial over how many you're going to choose, and then the difference of how many you're going to choose from how many that you have. Make sense? 4 and 3 is 7, so it's always going to work out that way. You'd have 7 if that's how many we have to choose from. We're choosing 3, and then 4 would make up for that. So when I do all the math for that, I actually get 35 different ways. You can choose 3 children from 7 to do chores. Let's go ahead and write that down. I've got one more to show you. 5 cards are drawn from a standard deck of cards. How many hands consist of 3 clubs and 2 diamonds? So I've put this here for you. First of all, I hope we can all agree that this is going to be a combination. How many hands consist of 3 clubs and 2 diamonds? When we're talking choosing, 5 cards are drawn. That would be choosing. This is definitely a combination. But there's 2 different things going on here. So there's actually 52 cards in a deck. I don't know if you ever played 52 pickup, but don't. That's just picking up 52 cards that people throw on the floor. All right, so we've got clubs. There's 13 clubs. There's 13 spades. There's 13 hearts. And there's 13 diamonds. So if I'm choosing, how many hands consist of 3 clubs? Well, I'm choosing 3 clubs, or I should write, I've got 13 clubs that I'm choosing, and I'm going to choose 3 of them. I've also got another event happening here. I'm also choosing 2 diamonds. Well, there's 13 diamonds, and I'm going to choose 2 of them. So it's the same thing we did in the previous example, only you have 2 different things happening. I have this thing that's happening. I have this thing that's happening. I'm going to multiply them by each other. So this one would be 13 factorial over 3 factorial, 10 factorial, and I'm going to multiply that by 13 factorial over 2 factorial. How many I'm choosing? 11 factorial. So if I do the math on this one, this would be 286, and this one would be 78, for a total of 22,308. So I'd like you to take the rest of the time to get some homework problems done. I've already posted the answers to all the homework problems so you can figure out if you're doing it right or not. And tomorrow we're going to do this again. And we're going to do the homework in class together. So good luck, have fun, be good.